Hi, everybody. Join us for the next Gestalt IT Tech Talk, where we talk with Madhura Maskasky from Platform9 EMP. And we're going to be talking around the Kubernetes cost optimization and cost efficiency, how companies are solving the cost optimization problem using different layers of the FinOps landscape, and how EMP fits into the landscape. With everybody moving to the cloud, you have cloud FinOps, and autoscalers, and various tools on how to handle these. Well, today we're actually talking with Platform 9, who has a unique approach to this. Hi, everybody. My name's Jon Myer, and this is a Gestalt IT Tech Talk. And before we actually get to our topic, how about we give our guests a chance to introduce themselves? Madhura?
Yes. Hey, John. Good to talk to you again. I'm Madhura Maskasky, co-founder and head of product at Platform9.
Madhura, talk to me a little bit more about Platform 9. What is it?
Yeah, absolutely. So we're a company, we've been around for about 10 years or so. We specialize in providing distributed infrastructure management for enterprises running their private or hybrid clouds. Started off by providing OpenStack as a service. And then when Kubernetes was early, we adopted Kubernetes and we were one of the first providers of Kubernetes as a service as well, right? So today we have a lot of enterprise customers running both OpenStack and Kubernetes across really large sets of infrastructure, private or hybrid cloud. And then recently we launched a very new, exciting product, kind of really utilizing a lot of our experience and expertise in virtualization and infrastructure management. And that's what we're going to talk about today.
Oh, well, before we jump into what you just recently launched, can you tell me a little bit more about Platform 9 and what it isn't, though?
Yeah. So I guess what Platform 9 is, right? We're really focused on one thing. We want to enable enterprises to use their infrastructure regardless of where it's located, meaning it does not have to be located in the public clouds. It could be located in your private data centers or edge locations. We still want you to be able to manage that infrastructure with the same level of simplicity and agility like how you manage public cloud, and which is why we pioneered SaaS-based management of remote infrastructure as one of our first key parts of our offerings, right? And which was also has always been our unique differentiator. And with that, you don't have to manage that management plane software. You just manage all of the infrastructure that is running in your, data center or edge environment, and you focus on the workloads that run on top of it, and everything else is handled by us, right? So what we're not is we're not I guess yet another sort of infrastructure management software that you deploy on premises and manage, etc. We have a very differentiated approach towards how you manage your infrastructure.
All right, let's talk about what you just recently released or your new product that's actually just came out, because I'm really excited about it. We saw it in action. We saw a lot of information about it, but I wanted you to share it with the audience.
Absolutely. Yeah. So we're very excited about it. It's a brand new product offering from Platform 9. We've been working on it for almost a year. It's called Elastic Machine Pools. And like I said, it kind of lets us utilize a lot of our expertise around virtualization and infrastructure management and optimization, right? So Elastic Machine Pools, the offering is focused purely on public clouds and is focused on helping enterprises save money by getting better utilization out of the resources that they deploy in the public cloud. Okay, so there are many tools that are out there today already, right, that help people with infrastructure or cost management and optimization when it comes to running workloads in the public cloud. So many times we get asked the question, well, why yet another tool, right? So what we like to call out is that Platform 9 EMP is not yet another order scaler, right? There's many that are out there. It's not yet another instance right sizing tool or Kubernetes config right sizing tool. We have a fundamentally different and differentiated approach towards how we help you deploy that infrastructure in the public cloud, and therefore how we let you optimize it.
Madhura, you're focusing on EKS, correct?
That is absolutely right. Yes, the first version of the product is focused on AWS and specifically on EKS, which is their native AWS's native Kubernetes offering.
All right, cool. So let me dive into that a little bit. You're telling me that it's going to be more efficient when you're running EMP for it, but I really want to understand, when you say more efficient, how are people utilizing EKS right now? What percentage of EKS is actually being used or optimized to efficiency?
Yeah, I think that's a great question, right? And it was kind of some of our observations around this really led to us wanting to kickstart EMP as a project. What we've noticed across our own EKS deployments, across public clouds and private, and across number of our enterprise customers and prospects we interact with, really large organizations, what we've noticed is that on average, a Kubernetes cluster utilization, and this is especially important in public clouds, but it's true in general, tends to be somewhere around 30% or so, right? Across your compute CPU or memory resources, whichever one may be the most constrained one. And so if you think about it, especially in the public clouds, about 70% or more of those precious, really expensive cloud resources are going waste on average. Right. And this is not just our observation. Datadog has had a recent sets of reports. One in 2022 spoke about how 45% containers use less than 30% of the requested memory. Right. So it just kind of contributes towards that problem. And so the question we were asking was, well, why, despite there being so many tools in the market that are, that help you optimize this, why this statistic still exists? And that kind of led us to create EMP.
Madhura, 70% is waste, which is amazing to me because I thought Kubernetes, I thought EKS, I thought all that was supposed to solve this waste and have an efficiency throughout your container, throughout your environment. But 70% is not being utilized and it's just sitting there idle. Like it's just extra stuff that can be really used efficiently within your company.
That is absolutely right. Yeah. And I think the issue is today that there are multiple tools that DevOps teams can use to attack that problem. But the approach that those tools take result in, you being able to make a dent at maybe 10%, maybe 15% of that 70% bucket, right? It also results in there being a lot of back and forth between DevOps and developers who are owning setting those request and limit values for their apps. And there tends to be a lot of pushback between DevOps and developers on trying to adjust those values, optimize them, etc. So a lot of additional work. And our approach is to completely simplify and automate all of that.
Madhura, what do you think some of the biggest sources that lead to cost efficiency are, though?
So there tend to be two biggest buckets that result in cost inefficiency when it comes to running Kubernetes in the public clouds. First one is what's called bin packing inefficiency or overhead, where your instances are just not packed, or your workloads are not packed nicely, properly enough with or using the instances that AWS offers to you, right? And there are actually tools today that help make a dent towards this. Carpenter, an open source tool from AWS, is an example of such tool. But then there's this second bucket where your developers are requesting by setting request and limit parameters a certain amount of resources. And 90% of the time during your app's lifecycle, those resources are not getting used, or maybe a very small portion of them are getting used. And it's this second bucket that tends to be very difficult to optimize. That's where there's a lot of back and forth between ops and developers, even using the tools today. And that's where EMP, with its unique approach, which we'll talk about in a minute, really kind of makes a dent by operating almost at a layer below, at the hypervisor layer.
Medora, let's talk about a little bit more about the unique approach for EMP because before I actually jump in there, and I know we're talking about FinOps and some of the things that go in involved into it, but here's what I'm thinking. I really want to ask the question, what does this have to do with FinOps? But if you can't actually see the value of the cost optimization savings that you're doing of getting rid of that saving, that 70% of waste, that is huge for this. But what is the unique approach for EMP?
Yeah, absolutely. So, unlike all of the existing tools today that kind of operate at that Kubernetes layer or provide observability or go one step further to adjust your request limit values, EMP operates at a fundamentally different layer. Okay. So what we do is instead of you provisioning EC2 nodes as your worker nodes for your EKS clusters, we enable you to provision bare metal nodes in AWS, for example. AWS allows you to deploy EC2 instances that are bare metal instances, non-virtualized, right? For every instance type and family and configuration, there's a corresponding bare metal instance available. And that's really what we tap into. And what that allows us to do is, again, it allows us to use our years worth of expertise, coming back from VMware, which I myself and my co-founders spent, several years working on these problems, it allows us to utilize those expertise there. So what we then do is we create a pool of these bare metal nodes in AWS, and then on top of that, we deploy our own virtualization, right? We deploy our own hypervisor, our own virtualization, and then using that, we create an alternate layer of VMs on top of that pool of bare metal nodes, and we call them elastic VMs. And so these elastic VMs become worker nodes for your EKS clusters, right? And so from your perspective, you can see these EVMs just like your regular worker nodes in your AWS console. There's nothing different about these EVMs. You have complete freedom and flexibility to do all of your EKS operations exactly the way you do today, no restrictions. But behind the scenes, these EVMs are highly optimized to make best use of that bare metal capacity that is deployed.
Madhura, you're talking about some of the approaches that EMP does and handles it, but how are others approaching the FinOps landscape?
Yeah, so I think the other tooling that ends up approaching this problem is typically by making configurations at the or changes at that Kubernetes layer, right? For example, automatically editing your application's requests and limits value is one common approach taken towards it. And there are tools that use a lot of heuristics to try to do this, but that's always an imperfect science because the developer really knows what's that max value your app is going to need, or otherwise it's going to get boom killed. And there's a lot of resistance from developers on some automation tool trying to tweak that value because their SLA will get compromised by that, right? But we also think fundamentally that's not necessarily the right approach because your infrastructure management, we believe, should be done based on the actual consumption of resources, not always based on how much resources you think your app will require, and hence you set the requests and limits. And that's the approach EMP takes. So EMP will over provision these set of EVMs that we deploy on the bare metal, right? That's one of the big principles EMP applies, which is you over provision resources, you pack more VMs on fewer set of bare metal nodes, and you kind of apply the statistical multiplexing principles there, where you assume that not all VMs are going to be using all resources they've been given. And these are, by the way, practices deployed in private clouds for years, right? And then to tackle the issue that maybe all of the VMs will start consuming all of the capacity that's given to them on a single bare metal node, which can happen rarely. To tackle that second issue, EMP has its second counterpart, which is a patent pending component for us, which is called the EMP rebalancer. And that is dynamically auto balancing capacity across this pool of bare metal nodes by live migrating VMs, right? So it's something very unique that we're doing in the public cloud. It's really never done before in AWS, where we live migrate VMs from one bare metal node to the other. So the parts don't even know that your VMs changed place. But your VMs suddenly now are in a position where they can get more resources if they require them. And so we're able to satisfy the app SLA without any disruption to your applications.
Madhura, here's where I see your layer. And when you say a layer approach, I'm envisioning a cake, and where traditionally the autoscalers kind of take place is at the top layer, like the icing layer, and maybe a layer below. But where EMP is actually handling a number of it is actually in the pan where the cake is baking. Everything it's taking it from the core layer and it's handling everything, the AWS, the bare metal nodes, and that's where it's managing the aspect of it rather than at the top layer where it's probably at the last line of defense in my consideration where I'm envisioning things.
That is absolutely right. I think that's a really good analogy. MP really operates at that bottom layer, and so you have more control, more visibility into the under the hood operating or things or resources, and more ability to optimize.
Here, do you have some real world examples where EMP comes into play for a number of your customers or companies?
Yeah, no, absolutely. So this is an early product for Platform 9, right? So it is in a design partner phase, and we're working with a number of design partners, collaborating them really large deployments where we're helping them save and optimize their infrastructure. Some examples I can quote: one of the data processing companies that we're working closely with, when they actually measured their true Kubernetes cluster utilization, EKS cluster utilization, by really methodically taking samples of average CPU and memory usage and then averaging over a long period of time, they realized that their actual true average utilization was somewhere around 17 to 20%. much less than what they thought it would be. And this is, by the way, yet another thing. Not everybody always has perfect, precise visibility and understanding into exactly how much they're utilizing that capacity. So, they really put in that effort and they realize that it's lower than they thought. And in their case, there was almost half and half wastage going across bin packing and then that, under optimized request and limit values. And with EMP, without going too aggressive with over provisioning, etc., we're able to double it, right? So we're able to take it from 17 to 20% to about 40% or so. And so you can imagine what that does to your nodes. It halves the number of nodes you need to deploy effectively, and that means your costs go down by half, right? So in their case, it was a multi-million dollar, close to $10 million or so of AWS bill, and we're projecting it to come down pretty significantly to about 5 million or so. And so that kind of hopefully lets you visualize the potential for this technology.
It always amazes me how much utilization somebody feels that they're using within their company. They're projecting that they want to be 60, 70% utilized on their instances, their bare metal, on their services. And when they actually get the visibility that they're only using, like your example of 17%, it's got to be a shock to them. And if you can double the utilization for them, the cost savings it right there is a no brainer. Like if you can cut everything in half for me in my utilization, and enterprise customers of dropping their bill, so much already exponent in millions of dollars, it's like sold. Let's do that, because if you can do it now at half, imagine what you could do in a longer time and really analyzing their environment to actually get to even more percent of utilization.
That's absolutely right. And I think the beauty of this solution is that we're able to do that without having other side effects like, oh, we have to take your apps down every once in a while, which number of tools in the space that exist today, they have those side effects, right? So our partners have told us we can't use Carpenter, for example, because it has this side effect that it will take down your pods every once in a while. And we can't afford that. We have these very heavy Java applications that can't afford it, right? Well, with EMP, that side effect is not there. So your apps will always stay running. So you have better SLA with the cost savings. And that ends up being very, very appealing to a lot of enterprises.
I'm not sure who it would not be appealing to have cost savings within their cloud environment. I mean, it's right there. I would sign up for that. Madhura, thank you so much for joining me. This has been an awesome discussion. Where could people go to actually learn more about Platform 9 and EMP?
Yeah, absolutely. So the best place to go is to go to platform9.com/EMP. You can find all the information about the product, watch a demo, and then sign up, contact us to find out more.
Well, everybody, this has been an awesome discussion with Platform 9, EMP, and Madhura. My name's Jon Myer. This has been a Gestalt IT Tech Talk.